Last day, we were discussing about lists, tuples, dictionaries, etc. So just a quick reminder on this. And so before we proceed to the next one, I would like to give you a quick reminder on the things that we have learned so far. So because like these things you need to remember in order to do the next set of activities, right? Okay, so we started with the general programming concepts. We started with introducing the software process and why software process is critical. And then we have learned about the steps of software engineering. And so under steps of software engineering, we discussed that this part that we are doing now is coming under the system design and development. This is actual coding happening in the development part. System designing is where the flowcharts and pseudocodes come. Actually, flowchart is a kind of design tool, so which is using less words but more pictures or symbols. Why? Because then so it can minimize the ambiguity of the natural languages. So when you have a flowchart as the design tool, so it is very clear, limited set of symbols, globally accepted, globally available. Anyone can understand. So starting and stopping denoted with the ellipse, as well as the process is rectangle. Output inputs are shown using parallelograms, decisions using diamonds, connections, and data flows. So simplest control structure in programming is selection. We learn about that. We learn about actually three programming control structures, three control structures. The first one is selection. The second one is, first one is sequence, where the instructions are executed one after another. You can see this is simple mechanism where all the instructions come one after another. So start, then the input, then the process, then the output, and stop. So it is simply an order. This is sequence. Selection is where you have to decide, you have to select a path. Actually, in the sequence, all the instructions in the program are executed. All these instructions are executed in sequential order. But in the selection, you are not executing all the instructions. Instead of that, you are selecting alternative paths. Based on a condition, you are selecting some alternative path. That is selection. And repetition is where you repeat the same set of instructions again and again. In sequence, we can use normal operators, inputs, outputs, etc. Selection, we are using if else for the conditional statements, if else, elif, if else, etc. And for the repetition, we are using loops, for loop, while loop. These are the things we are using for repetition. We learned that about that too. Then actually we have learned about the operators and also about the Python programming language, and it is so how translation happens, interpreting, and the compiling. Compiler translate all at once, interpreter translate line by line. Actually, in Python, the translation happened by interpreting, statement by statement or line by line. But Java-like programming languages, it is compiled. Entire code is translated at once. Why translation is needed? Because so in the computer, we are using machine language, ones and zeros. Machines can understand this on-off signals. So, but we are using words. These words computers cannot understand. Therefore, you need translators to translate these words to the numbers or the machine codes. You need translators. Okay. Then here we are using ideally, and we learn how we can use identifiers. So especially when naming identifiers, there are restrictions. We cannot start identifier name with a number. We cannot keep spaces in the middle, and we cannot use special symbols. Other than that, if you are starting with underscore, or if you are starting with a letter, it is acceptable. Then we learn about the mathematical operators. So operators can be applied to the numbers, and operators can be applied to the variables too. So we learn about exponent, power, plus, minus, or unary operators like single, like negative, positive. This is actually not plus, minus. These are negative, positive, positive, negative. This is exponent, power. Then the multiplication, division. So this is actually in order, right? So first the power will be executed. Then the negative positiveness will be considered. Then the multiplication, division, modulation. So multiplication multiply, division will divide, modulate will give you the remainder after division. When you modulus, after dividing, what is the remainder? Integer remainder. And the floor division will give the least full number or least integer number. So this is also called integer division, because you are getting the integer value only, not the decimal value. Then the plus minus addition. Actually, this shifting operators we have not learned, and all these operators we have not learned, but we have learned the membership operators, whether it's there or not. Is it in or not in? Then we have learned the comparison operators, greater than, less than or equal, greater than or equal. So these things, and assignment operators. Assignment operators, the specialty is something like this. So let's use ideally to quickly go through the assignment operators. So in case if you cannot remember, just tell me. I can explain this to you. Example. So you can say x equal 10, y equal 5. So then these are assignment operators. Assigning value 10 to x, assigning value 5 to y. Okay. Then if you say x equal x plus x equal x plus 2, the current x will be 12, because already it is 10, 10 plus 2 is 12. So this can be done similarly, x plus equal 2. This is also x equal x plus 2. Currently x value is 12, 12 plus 2 will be 14. So now current x is 14. So this is what the assignment operates. Let's say x divide equal 2. So x will be divided by 2 and then will be equivalent. So that means x is 14, 14 divided by 2 is 7. So the value will be 7.0 if you print this. So likewise, okay, let's get the modulus. X modulus equal 3, x will be divided by 3, the remaining will be 1. So what is x? It is 1.0, because this floating point number. But if you need the integer value, you can just divide x floor division by 1. So you are getting 1 here. But if you need the integer value, you can get intx, that will return only 1. Okay, that is it. So we have learned about this conversion, typecasting, etc. For an example, if I ask the type of 1, so this will be string str, but type of 1 is integer, because it is not inside the quotation. But if I ask type of 1, and if you cast this to integer, the string will be converted to integer, so the result will be int. So string can be casted if it is a number. Right? Similar way, you can cast, let's cast str1, then you will get within quotation 1. This within quotation 1 is also string. Right? Likewise, you can typecast the operation and you can cast it to float 2. Let's say float 1 is basically 1.0. That is casting that to a decimal number. So typecasting or change in types can be done in str, float, these operations. Okay, so up to now we have learned about those things: operators, variables, identifiers. Yes, we have done. And we learned that even the characters are having values. Therefore, you can compare characters. For an example, if you compare hello with hello, it says true because the capital H is less than simple h. You can get the value of that by referring to the ORD function. ORD H will give the value of H, it is 104, and ORD H will give the value of capital H, which is value of 72. That is why when you ask hello greater than hello, it says true, because this hello, only 72 is the value of H. The simple H is higher than the capital H. All the characters are having values. So if I say for K in my name, let's say to my name, oh, if I want to print this, I have to use colon and print K. That will print letters in my name. We learn about the strings. And if you want the values of these letters, you can say print ORD of the particular letter, you will be getting the value here. Right, I'll give you a small exercise on this because this string part we have already discussed, but let's do some interesting exercise using this. So similarly, so if you have the CHR, so let's say you have a set of numbers. Let's say you have numbers from, not this, you have numbers, some numbers for, let's say J in range, you are starting from number 65 and going up to number 100. And if you are printing J with ending space, you will be printing numbers from 65 to 99. But let's print the CHR values of this. That is basically the character values. What are the characters? You can get the CHR values, then you will be printing the CHR here. So A to Z, then you can say after Z, the brackets, notation, caps, and simple ABC comes. Simple A is 97, 98, 99. You can see simple letters. So likewise, if you have the character numbers, let's say you are writing up to 300 even, you can get the character values. These are all assigned, you can see. So some are not non-English characters, right? Some are like non-English characters, Spanish and all will also be there. So anyway, for all the numbers, there are characters. Almost all the numbers, there are assigned character actually, because we are having something called ASCII. ASCII has only 256 characters, but there is something called Unicode. In Unicode system, there are 65,000 characters. Therefore, you can print this up to 65,000 even. So there will be a lot of characters, but this is a big number. So let's say 65,000, that is a bigger number. It will take a lot of time to print these characters, but let it be. And you can see these are the characters that printed and keep going on. You can see it's keep going on. So it will be printing different values in different languages. These are all Unicode characters, right? But it's memory consuming operator as this loop runs through. Okay, you can see it's a lot of memory consuming operator. Just try to print all the characters, but it will slow down because it consumes a lot of memory. Around the 3,000 singular letters are there, but I'm not sure whether that will be printed here in the terminal. But around 3,000, there are singular letters too. Let's cancel it out with the keyboard interrupt. Let's try to print 3,200 something here. So there were some 3,100 maybe. Not sure whether, yeah, some, these are not singular, non-singular characters. Yeah, some, I think Thai or some other character, it seems. But still, those will be get printed and no singular character yet. All are some other characters, right? Seems. It depends. I think these questions come when these are Tamil characters. You can see some Tamil characters are listed. Maybe after that, all are Tamil characters, right? You can see. Oh, these characters will take a lot of time to print. So anyway, so there are a lot of characters. These characters are having character code. That is what you need to remember in this spell. So there are characters and these characters are having character codes. Okay. So how to get how to convert number into a code? You can use the CHR function to code. Here you can see. So the single letters will also be printed, right? Those are also there. Right. Numbers to characters. Characters to numbers. CHR will convert number to character. ORD will convert character to number. Right. A simple exercise using this. This is related to strings, but let's do this simple exercise. Okay. So, because like with more exercises, you can prove the knowledge. Okay, this is my exercise. ORD function, please write down, will convert. ORD function will convert given character to its number representation based on ASCII. This is called American Standard Code for, that is a mechanism, right? Information interchange. That is a standard way of representing characters based on ASCII or Unicode character representation. Unicode is also similar to ASCII, but Unicode has bigger scope. ASCII has only 256 characters maximum. That is the extended ASCII. Normal ASCII has only 128 characters, only for English. But extended ASCII has more characters. But Unicode is having like 65,000, very big character scope. It represents China, Chinese, Mandarin, Tamil, Sinhala, all these characters, Thai, from all over the world. So it has a unique code on that. Then CHR function, actually you have to write CHR in simple, right? Otherwise it won't work. ORD in simple O. CHR function will convert given character code to a number. So they give a CHR given character numbers, given character number to the character. From ancient time, message encryption was used in secure communication. Please write C is a cipher. Caesar. So you know the person, right? Caesar, Julius Caesar. C is a cipher. Was used by Julius Caesar during wartime. It is also called monoalphabetic Caesar cipher, where one character was replaced by another character. Example, let's say there's a message called hello. So this can be referred as plain text or original message. And that is converted to something called, let's say, HIEF, then LMMOP. So this is called ciphertext or encrypted message. Advantage is it is difficult to an intermediate person to directly understand the message without knowing the encryption method. Later, disposition methods and keys were also added to make it more complex. Example. So let's say there's a message called hello. This hello world. This is your original or plain text. So what is disposition? So disposition was done this way. You are writing this HELLO space. It's writing downwards, right? HELLO, let's say capital. Hello. HELLO space world. WORLD, right? HELL. So please read this way. Please read this right before writing. Please understand. HEL, then LO space hello world. WORLD. This is written as this, but when you are sending this message, it is sent as this. This is called disposition. Disposition of characters. This is encrypting by disposition of. Then it's very difficult to read. Right? This at least you can guess H not I instead of H I is used. It's instead of E F is used. Instead of L M is used. Instead of L M is used. You can at least guess this, but this is difficult to guess. Key is basically another character, another set of character. What is key based thing? So key based encryption. So this is security lesson, right? This is security lesson, but all three can be implemented. The key based encryption example is something like this. You have the message, let's say hello world. You are adding a key. Okay, a key is something, let's say key is ABC. And ABC again, ABC again. So value of this will be added. H plus A. A means one character, then only one, the first character. H plus A, HI. B is the second character, then E, Two characters, no, B can B second character, A, B, D second character, so E, F, G. C is third character, L, L plus 3. L plus 3 is L is L, M, M, N, O. Then A, then again A. So let's write this in Korea. This is also in Korea, so easy to. Korea is only taking single same space, right? That is why, or it's taking similar space in each character. A plus H plus A is character 1. So tell me if you cannot understand. H is a character, A is only one, the first character. So H plus 1 is I, next character. Then E is E. E plus 2, B is second character, no? E is B is second character, then A, B. E, F, G. L is L, C means third character. Third character example, this is an example, right? But these are having actual values, not 1, 2, 3, these are having different values. So then what will happen? L plus C is L, M, N, O. Then next L is not O. Actually here both L's are O, right? This L is M. This L is also M. Both L's become M's. But here both L's will not become O. This L is because of C, it is O. This L is because of A, is only one character, L, M. O. O plus C. O, P, Q, O, P, O, L, M, N, O, P, Q, R. So this will be R. So this is the key-based method. Then space. So after space, what is the character? So the two characters will be, let's keep B as it is. The world, W, and X, O, A, C, A, here actually A, B, C, A, C, B. Oh, this, there is a problem. So this is A, C, B, A, C, B, right? So let's add A, C, B here actually. ACB is the key, ACB is the key, ACB is the key. So this is A, okay, C is E, F, G, H, sorry, H, L, B is 2, B is 2 means L, M, N, L, M, N, M, N. This L plus A, this plus C, O, P, Q, R. This is B, W plus A, W, X, O plus C, C, O, O, L, M, N, O, P, Q, R. Yeah, again R. Then R plus B, R, Q, R, S, T. L plus A, L, M. D is here, A, C, B, A, C. Again, D plus C means D, E, F, G. Okay, you can see this is the message. The key is repeated and the key value is added. So this is the key-based encryption. So likewise, different encryption methods were used. Encryption is why, because you know, in the war, during wartime, the Caesar had a big problem because this enemy is trying to fetch or understand Caesar's secret messages. These messages were sent through messengers. You have seen the horse riders. So they were like sending messages from one camp, one army camp to another army camp. That was happened basically that time, right? So when they are sending the messengers to the messengers, the enemies used to capture these messengers in the middle and try to read the war secret messages. So that was headache to the Caesar. So Caesar decided not to send a plain text message. Let's send encrypted messages. Actually, in today's world, how encryption will work, because no war is there, but there are hackers. When you send plain text messages, even the passwords, emails, account details, right? I think you have seen this in some websites. Some websites are having this padlock. Showing this padlock indicate there is a security. Security means the message is encrypted. Here you can see the message. Here you cannot read it. It is encrypted, jumbled, mixed text. It is basically encrypted. So that is happening because of this is HTTPS. If a website, let's say www.nie.lk, so you can see here not secure because this encryption is not there. But if you try to access https://www.nie.lk, you can see the padlock app. Oh, it is not there. Is it? Yeah. nie.lk, you can see the padlock appears. Still, the HTTPS is not valid, right? You can see that's not valid there. So it says the encryption is, the certificate issue is there with the encryption. There are a lot of things related to security. This is a different subject, IT security. If you are interested, I can teach you, because I have learned ICT security as well, and I have done EC Council, CEH, Certified Ethical Hacking, and all. So if you're interested, I can teach you that side. But before that, you need to learn programming. And basic is the programming. If you know the programming very well, then you can, here this is saying this is not using encryption. But if you're using a website, like let's say you're using a PayPal or something, so when you visit the particular website, it comes with the HTTPS, because it need to be secure. The transactions, whatever you are doing, things need to be encrypted. Otherwise, what will happen? In intermediate hacker can get details of that. So that is why the encryption is there. So this is a big question, but this has interesting point. ORD and CHR function will help you converting numbers to the text and text to numbers. So that can be done using this ORD CHR functions. And then I have given methods. So what are the methods? The first one is replacing character from another character. Replacing one character from the next character. Maybe next immediate character or next two characters, whatever. You do simple increment. Each character will be incremented by 1 or 2 or 3 or some number. That is the simplest one. This is similar to monoalphabetic Caesar cipher used by Julius Caesar, very simple one. Instead of hello, you are sending some other message. When a messenger is captured with this message, the messenger will be confused. What is this? He cannot read the message. It is jumbled. Right? That is the thing. Even the messenger doesn't know. So the algorithm of reversing that, but the Julius Caesar's army, the other party, knows how to decrypt the message. That is called decryption. The other hand, the decryption happened. This end, the encryption happened. So encryption will convert plain text to ciphertext. I'll add that part also. So what is encryption? Is basically converting ciphertext to plain text. Is called, other way. Plain text, converting plain text to ciphertext. So actually decryption is the reverse. Decryption, converting ciphertext to plain text. So that is called a decryption, the reverse. Actually, algorithm is known by both parties, encryption party and decryption party. Both parties know the algorithm. They do the conversion at the end. Right here, Julius Caesar had sent the encrypted message. Caesar's army, the other side, know how to decrypt and get the original message sent by the Caesar. But the thing is, this is easy to guess. Therefore, there were different methods. This is like a shuffling, or the change in the position of character will be really complex. Then it's very difficult to read it out. What I have done, I have written down like 3 by 3 downwards and then took horizontally characters. Let's say something like hello world was there, but I have written downward HEL, then L again, O again, then this is not there, the space, then the W comes, world, WO, R, L, D. This is written as that. Then the reading happens this way. So you can see it's very difficult to read when it is read like this. So if it is a large message, very difficult to find that. That is this shuffling or the disposition. Together, both this and this can also be applied. Shuffled and also character is also replaced. After shuffling, you can replace the character, then it will become more complex. This is even more complex because random key is sent. Without the key, you can't decrypt it. So key should be a secret message known by both sender and the receiver. This is called secret key algorithm. In the secret key algorithm, a secret key is used. Actually, the message, this secret key is added. You know, there are some viruses called cryptoviruses. Have you heard of that? Tenoka? Cryptoviruses. Have you heard of that?
Is it the mining or?
That is cryptocurrency. The mining thing is cryptoviruses. Basically, when these viruses come, it will encrypt your files in your computer. All the files will be encrypted. And then they are asking you to pay a fee. If you want that original files back, you need to pay them using cryptocurrency and get the unlock code. Actually, what they are doing is they are encrypting, they are adding a key. Using a key, they are encrypting all these files, Word files, document files, pictures, everything will be encrypted. But they only know the key. Then what will happen? If we try to open the file, it says the file is corrupted, encrypted. We cannot get our data back. So what they are doing, they are showing some message in your screen saying, hey, we have encrypted your data. So if you need your data back, you have to pay us and get the decryption key. But that is not a sure thing because like we cannot trust them. They are sending us a crypto address to pay. So we don't know where these people are and whether they will really give us the decryption method. We cannot trust them. The only solution is having backups, copies. You can erase the encrypted copy and get a new copy. That is a very good solution that you can do if you don't have a copy. So you can delete all the files and try to recover the data. But paying them is not recommended, right? There are such viruses. So these viruses are so dangerous because cryptoviruses. When a cryptovirus comes, very, very dangerous because like, you know, so it will lock your file. And so here, hello Alice will be encrypted using a secret key. So that is known by only the cryptovirus provider. Yeah, your personal files are encrypted. If you need that, you have to pay this amount and get that file back. Then only we will give your files back. So that is the, here you can see all the files, you can see those are encrypted. You cannot use them after. These are called ransomware too. Cryptoviruses are also called ransomware. Have you seen this kind of viruses? No.
I've heard of ransomware.
You heard of ransomware is a cryptovirus basically. Right?
Yeah,
Ransomware is a cryptovirus. Once attacked, your files are gone. So one way is getting is paying them and get the key, but it is not recommended because we can't trust these people. Their intention is to earn money through our data. So we can't try anyway, we can't trust these people. So one solution is use proper backup. So if you have important file backup, at least in our Google Drive or some maybe iCloud or Google Drive somewhere, then we can at least refer those data and get them back. Even mobile phones are now giving this backup facility. You know, Samsung, they are having Samsung Cloud. Apple, they are having iCloud. So different cloud storages are there. So that will anyway help you in case of attack or virus. So you can at least format your device and get that backup downloaded back to your device and use it. At least that copy will help, right? But there are situations where the backup and both original get infected with viruses, then you are gone. That can also happen, right? Anyway, if you have important data, especially it is related to your examinations and especially personal files, if you need to keep these videos, pictures with you. So if it is so important, it is recommended to keep a backup because of these behaviors, because these are so dangerous. Anyway, now you know, so this is a security lesson, but I just need to show you the importance of programming in security. That's why I have given this exercise. Actually, I couldn't give this to your friends too, but anyway, I'll give it to him as well. This is one important area where the security merge with programming. Right, now you know 3 ways of encrypting. So I don't want all 3 methods. So this is the easiest way is monoalphabetic. The shuffling is difficult. So here using a key also encryption and decryption can be done, but keep that aside. So let's try to implement the first one. I need you to input a message, okay, like this. So let's say there's a program in this program, I'm writing, let's say, plain text. We are basically inserting input, enter a message, and this message that you're reading here is the plain text. What you need to do is you have to encrypt the message, and so what do you need to print? Encrypted message. So print encrypted message. And the second thing is get the ciphertext, that encrypted text, that is ciphertext, and decrypt it and print the decrypted message. Here the comments I have added comment. Comment is do nothing but just showing you what to do. Print decrypted message. Okay, this is small challenge. So just do this for first one means like this monoalphabetic exercise. Try to do this for the first one, please. If you need to write down here, it is. Please write down the note and then, oh, not this, sorry, my mistake. The ideally part should come here. Okay. Try to do this. Okay, so see here what I have done. I have just accessed letter by letter and printing the letter and ending with space. So let's see, let's run the module and see. So what will happen with this? And it's asking the message first. Let's say my message is this is my secret message, and you can see this is my secret message, and enter message will come again. So this is actually decryption. Let's comment this decryption. I just need the encryption only. Run it again, and you can see it's asking the message. Say hello world. This is a secret. You can see hello world. This is a secret. It's printing down letter by letter. But what you can do instead of printing letter by letter, you can get number by number, right? So how you can get numbers? So what is the function to get the number? Convert this to a number.
ORD.
Yeah, ORD. You can just ORD this. When you ORD, what will happen? So you will not be printing the message. Instead of that, you are printing the number. Okay, let's say this is a hello world, same message. Hello world. It's printing the character sequence, right? You can see here. It's not printing the message. Instead of that, it's printing the character sequence. The 32 is space. Other characters are accordingly printed. Now, what you can do, actually, you can add 1 to this, right? Because this is a number. Adding 1 will not do anything, right? Can we add 1 to number? This is 104, 101. So these are numbers. Just add 1. So let's see what will happen. Okay, I'm typing hello world. This is my secret message, and it's printing this time not the same. 105, 102, 109. You can see 1 added to the number, right?
Yeah, so, yes.
It's easy. Then what you have to do? Convert back to character. Right? That's all. Convert back to a CHR is converting back to a character. So then you can convert back to a character. Then what will happen? Okay, you have hello world. It's converted into the number, add in 1, and then convert back to the character means. So this is what you are getting. So this is the encrypted message, right? So if you just remove the space here, let's remove the space here and see what will happen. Let's type hello world now. And you can see this message comes. So this is what I need, right? I asked for this. That's why I said it's a very simple code. Understood?
Yes.
And if you add 2 or 3 or 4 or 5, whatever, let's say you have add 1,000 to this. So then total jumbled message, because it will be converted to some other language even. So let's say hello world. What will be there? Here, this is so unreadable, right? Can you read this?
No.
I can't. So this is adding 1000 to that. So how to get that back then? Do the reverse. Type it. Then for letter in this, copy paste the same message. Then what? You have to reduce 1000, right?
Yes.
So it's straightforward and easy. So try other methods also. So you can try the other methods. So this is hello world, and you can see this is message, and so this message, if you copy and paste here, and it's getting this. Oh, why is that? Value where CHR. You have to do the other. Sorry, you have to get the for letter in plain text. You have to get the character. ORD of that character, and here's hypertext. Sorry, it's my mistake. Be careful with the conversion. Let's print a new line here. Make a difference otherwise. All right. Okay, let's put hello world there. Okay, enter the message, and this is not secret. Let's copy and paste this message, the secret. This is happening the other end. When you print the secret, you get the hello world back. Right? So this is what actually Julius Caesar didn't have this kind of convenient method of converting. If he had, definitely he will encrypt the war in its maximum capacity. But the thing is, he was doing this manually, right? He's doing this manually. See how with the technology and the involvement of the programming language, how easy that is. And you can see this is totally like mess up messages. You cannot read anything at all in other language. And it's not hello world, of course, but you are converting back to the normal. You will get the decrypted hello world. So that is not just for hello world. So for any message, you can, even for your name, you can convert, right? When you run this, so let's write the name. And this is my name. Unfortunately, what is this language? I cannot understand anything at all. Yeah, it's converted back to the name. Okay, that's it. Right. So now you have a work to do. Please take a screenshot, do this. So try to implement the other two methods. Right? We have some time next week. Maybe tomorrow we will be doing the class, and so try to convert the other thing. Means like this one, shuffling. You can just give a try, but shuffling is difficult. Let's give a try to this key-based one. Key-based one is easy. Shuffling is little difficult because you have to write it downwards, horizontally, right? You have to read it horizontally like this. More work, no? So let's try to do the key-based one. This one. Okay. Give a try, right? Have you finished writing down this?
Yes.
Okay. Then I'll be stopping from here. Let's do the class tomorrow, right? Okay, we're done.
Goodbye.